In this video, we're going to cover synthetic division, where we divide one polynomial by another polynomial. You might choose to refer back to a previous video on synthetic substitution in order to understand the process of the multiplying and adding steps. This video is going to focus on what to do once we've done our synthetic substitution process. At first, what we're going to do is we're going to look at our problem that says to use synthetic division to divide the polynomial x cubed plus 4x squared minus 2, and we're going to divide that by a polynomial of x plus 3. Just kind of as a reminder, there's basically two steps once we've set up our problem. We're going to add down, and then we're going to have to multiply diagonally. In our setup, what we want to do is we want to take the coefficients of our polynomial to begin with. I have 1x cubed. We have 4x squareds. The next thing we have to be careful about is we're trying to figure out how many x's we have. And you might notice that in our polynomial we don't have any x's. We do need to record that information as having a 0x. We'll also look at our minus 2. The next piece of this is to take a look at what we're dividing by. We're dividing by x plus 3. One of the keys in synthetic division when you're dividing is whenever you have a number inside of the parentheses or inside of the factor of x plus 3, anytime we pull it out of there, we need to change the sign of it. So I'm going to pull out the 3. We'll put it as a negative 3. In our box. This number is going to be our multiplying number. So every time I'm multiplying on this particular problem, I'm going to be multiplying by the number of negative 3. So our first step is to add down. I'll take the 1, we'll add straight down. That's a 1. Our next step is to multiply diagonally. So whenever I take the 1 and multiply diagonally, I'm actually multiplying by the negative 3 number that we had set out. So 1 times negative 3 is negative 3. We'll add down. 4 plus negative 3 is 1. We'll multiply diagonally. 1 times negative 3 is negative 3. We'll add down. 0 plus negative 3 is negative 3. Multiply diagonally. Negative 3 times the multiplying number of negative 3 is 9. And then we add down one more time. Negative 2 plus 9 is 7. Now this is exactly the same process we would have done before in our synthetic substitution. And in that synthetic substitution, we would have actually said the answer that we were interested in is in our dotted box at the bottom. We would have said that we were interested in this value of 7. In the process of synthetic division, though, we have a quotient, and our quotient sits at this line, and we have a remainder. So our remainder is actually over here of 7. Okay. So one of the things that happens in synthetic division is when we do a synthetic division problem, the polynomial that we started out with of x cubed gets reduced 1 power. So I started with an x cubed polynomial, and whenever I look at writing it down, I'm actually going to write down from my quotient part, it's going to have an x squared. So this is a 1x squared plus a 1x minus 3. So that's the quotient part. Our remainder is 7. And whenever we write it down, our answer to our division problem is going to be the quotient that we had of x squared plus 1x minus 3 plus the remainder that we had. So the remainder we had here was a remainder of 7. So we're going to take our remainder and put it up top, over the divisor that we had. Our divisor was x plus 3. Not just the negative 3, it's actually the polynomial that we had that we were dividing by to begin with. So on this problem, we'll see that we have a quotient plus a remainder over the divisor. Our quotient came from our answers down here. The remainder was the value that ended up in that box. And the divisor is what we had to begin with, the x plus 3. All right, let's take a look at our next example. On our next example, we have a polynomial which is 2x to the 4th plus x squared minus 1. We're going to divide this by x minus 2. So we're going to set up our synthetic division by peeling off the coefficients of the polynomial 2x to the 4th plus x squared minus 1. We do need to make sure as we do that, though, that we're filling in any missing zeros. So I have 2x to the 4th. I have 0x cubes. I have 1x squared. There are no x's. And I have minus 1 as my constant term. I'm dividing by x minus 2. So in this division problem, x minus 2 is the factor that I'm looking at, but once I pull it out and put it in the box, I'm going to change the sign of it to be a positive 2. And our steps that we have are adding down and multiplying by diagonally. And on this particular problem, my multiplying number is going to be this 2 that I put in the box here. So as we go through our process, we will add down. We receive 2. On our multiplying diagonally step, we're going to multiply by 2 on this problem throughout. So 2 times 2 is 4. We'll add down. 0 plus 4 is 4. We're going to multiply diagonally by the 2 that we had. 4 times 2 is 8. We'll add down. 1 plus 8 is 9. We'll multiply diagonally. 9 times the 2 gives me 18. Add down 0 and 18. We're at 18. And multiply by the 2 again. We have 36. Last step of adding down here, negative 1 and 36 adds up to be 35. Okay. So that was the synthetic part. Now we have to understand and interpret the pieces that we have. So the part that we have below the line here is our quotient that we need to write out. The piece that's in the box is our remainder. And as we said, whatever the degree of the original polynomial is, it's going to be reduced by 1. So I had an x to the 4th. So whenever I write down my quotient down here, we'll write it as a 2 with an x cubed, 4 with an x squared, 9 with an x, and the number 18. And so this is actually going to be our quotient. So we'll take our quotient, and we need to add to that the remainder. Our remainder was 35 over the divisor. And our divisor on this problem was the x minus 2 piece that we had here. So we're going to divide the remainder that we had of 35 by x minus 2. Okay. So a few things to remember on this. A couple of important points are whenever we write our answer of a division problem, we put quotient plus the remainder over the divisor. Second thing to remember is that the quotient will be 1 degree less than the original function. When bringing the multiplying number out of the parentheses, you do need to change the sign of it. And then make sure that whenever you're writing out the original polynomial, that you fill in any missing zeros that occur. Any missing terms need to have a value of 0 plugged in.